Thanks for inviting.
Thank you so much, Victoria. And thank you so much for the invitation. I must say, I'm a bit more nervous today than I'm usually when I'm giving talks or presentations, because I'm at my own alma mater, Uppsala University, and I see many familiar names in the audience. So it's a great pleasure being back. And I just realized the last time I spoke to people at Uppsala University via Zoom was during my defense, during the pandemic in January 2021. So my background, very short, is I did a PhD at the history department on 18th century history. And after that, I switched to AI Sweden, the National Center for Applied AI in Sweden. And what I want to do today is, given all the talk about generative AI, to give you a short crash course in how generative language technologies work. And I think this is really important to understand a bit about the technicalities of these systems so that we can use these systems in the best possible way and in a responsible way. So the first part of my presentation will be about how do these systems work? And I will try to provide you with some of the terms that are used in the field to give you the toolbox needed to critically question and scrutinize the systems that you're using, or maybe that your students are using. I will also provide you with some of my own considerations that I think are important to keep in mind when using generative language technologies as a research tool. And then I will conclude my presentation with some thoughts on the role of the arts and humanities for the development of AI. So I will not so much go into how you can use these tools for your research, because I think this is really a question of your own expertise and the needs you have in your research. So I will focus on where I think the role of the arts and humanities is in the development of responsible AI forward. As a context, we are in the field called natural language processing, NLP. It's a field that aims at processing and analyzing natural language data with the help of computer systems. And within NLP, we have a subfield called natural language understanding, with the specific purpose to enable computer systems to understand and to generate text. Within these fields, natural language processing and natural language understanding, we work with something called language models. And I will go into more detail what these language models are and what they do, but very simplified, one can say language models are algorithms or statistical models that learn language by being exposed to large amounts of text or speech data. Nothing of this is really new, and I wouldn't be a historian if I don't go at least a few years back. So before 2018, the way natural language processing worked was we trained models for very specific tasks. So for each task, and with task, I mean, for example, a classification or a translation or a summarization, we would need to train specific models for these tasks. Then in 2017, Google published a new way of training language models called transformers. And with these new model architectures, something new became possible. And that is that we pre-trained models on large amounts of data so that they got a general understanding of how text or language work. And then these models could be adapted to different tasks, but always with the same model in the background. And then in 2020, another, you could call it paradigm shift, happened with the publication of the first GPT models. And GPT stands for generative pre-trained transformer. And what the generative means and the pre-trained, I will go into that a bit later. But this really was a wow effect in the field because these models proved to be very, very powerful. And they seem to have the potential to, for example, lower the threshold for researchers, organizations, companies to actually use powerful language technologies, because training models is quite resource intense, both in terms of the competence you need, the hardware resources you need, and the amounts of data you need. And these models have the potential to lower that threshold so that organizations, individuals actually can use language technologies to solve their problems. These generative language models also have the potential to enable new ways of gaining insights. And I think this is something that many of you in the digital humanities are interested in, how to use digital technologies to really ask new questions, to gain new insights from known or new materials. And finally, another aspect that I personally find really exciting is how these models are now contributing to humanizing the way how we interact with computer systems. So coming from previously being forced to learn computer languages to interact with your computer, you had to know programming languages, to the graphic interface where you could click on icons. Now you are able to actually communicate with the data in your computer or with your computer on your own terms, that is your own language. So very simplified, let's have a very quick crash course in how do generative language models work. We make an abstract example and say we have an alphabet that only contains 3 letters, A, B, and C. And we have a training data set consisting of 3 documents that you see here. The first step is we count, or we have the algorithm count. And that means we count how often do letters come after each other. So in this case, you see, okay, an A follows never an A, but an A is 5 times followed by a B, a C follows an A 1 time, and so on. We can then transfer this counting to a matrix, and then in the next step, transfer it into statistics or chances. And basically, it's of course much more complicated, but this is the basis of what a generative language model does. Because now we can start generating text based on this statistical distribution of letters. In a language model, this would be words or so-called tokens. So if we start with the input A, what the model does now is look what next letter or what next token has the highest likelihood to follow on this A. And in this case, we see, well, it's a B. And then it's an autoregressive model. So it continues doing this for every step. So now we have a B, and the most likely next token after a B is an A. So the model continues generating this text. So this is very simplified what lies at the bottom of generative language models. Let's pause here for a moment and realize that there's no relation to knowledge in these language models other than how often this knowledge has been represented in the training data. So one example, think about conspiracy theories. And conspiracy theories might be represented on the internet much more frequently or much more prominently than, for example, very specific scientific research results on the same topic or a similar topic. But these research results are maybe published behind paywalls and therefore not available in the training data. We can also do an experiment with our own research here. So if you think about your own field of expertise, how well do you think your field of expertise is represented in general English language model data sets that form the basis, for example, for ChatGPT? And I think this is also a good exercise to do with students when you talk about source criticism, the power of the archives, power of knowledge, and so on. So I did this with my own research. I thought about, okay, so what parts of the knowledge that I created are likely to have ended up in any training data set? And the result was quite frustrating because my dissertation is open source or open access, but in a PDF. And PDFs are not very likely to end up in training data sets because it's very complicated to process PDF text data. So the only text there is the short abstract available on Diva. I've also published an article in a German journal. However, that article is behind a paywall. So it's likely not included in any training data. And then there is a newspaper article about my research, and this article has really, you can literally say, whitewashed the results of my research, and, for example, excluded the names of indigenous women because they were too complicated. So there's not much left from the results of this research that are likely to have ended up in training data. But back to the generative models and how they work. So to summarize, we have a developer team that has selected the training data, usually large amounts text data from the internet, and then trained such an autoregressive generative language model. And these models are quite powerful because what we can do with them is we can interact in natural language, in human language. So we provide a prompt and the model generates a likely continuation of this prompt. We've tested this with the models that AI Sweden, together with RISE and VASP, has developed, the GPT-3 models. So here we have really tried to work with something called zero shot or few shot, where we take the raw model, provide it with a very short introduction called the prompt, which you see here on the left side. And this is where we push the model into the right direction, giving it like the tone or the task. So in this case, we ask it, this is a story about an egg. And then you see the model continued this prompt, the input, based on the principle of predicting the next word in the sequence. Another example, what you can do already with these pre-trained models is that you can use them for very simple classification tasks. And in this case, we provided a few examples. So for example, 1 + 1 is 2 belongs to the domain of math, and so on. And then we have the model continue the completion of the task. So there's a really important distinction to make at this point, because we have seen a lot of confusion about this in the last month since the release of ChatGPT. And this is that we need to make a distinction between language models, like raw pre-trained language models, and products or services built on top of these models. And why this matters will become clear in the following. Let's see. So if we think about the pipeline of taking a language model from the pre-trained language model to a product such as ChatGPT, there are many, many things happening in between. And I want to focus particularly on this adoption phase today, because this is something that I haven't seen a lot in the media when we talk about these models. The focus is always very much on this prediction of the next word, and that is certainly simplified true for all these products. But I think if we really want to use and understand these models in research context, this adoption and fine-tuning step and the productification step are quite important too. So I will focus on the second part, the fine-tuning and adoption part, and the methods that are used here and the choices that are made and that determine how you can use these models and what they actually do. So there are different methods in this step, and I will talk you through some of them. We came from pre-training a language model, which is done in an unsupervised or self-supervised way, which means we only show data to the computer and tell the computer, find the patterns yourself. In the next step, we apply something called supervised learning, which is much closer to the older forms of AI and the ways we have long worked with artificial intelligence. And another strategy called reinforcement learning, and I will talk you through this. So the first step that is done when we take a pre-trained language model and want to make a service out of it, we define what do we want the model to do. And in the cases that are most familiar to you, for example, ChatGPT or Bard, Claude, there are many different services that build on language models. The developers have made the decision, okay, we want this model to be, for example, a helpful assistant. Other words that you frequently find in their mission statements are, this is supposed to be a harmless assistant, or this is supposed to be a safe assistant, or a beneficial tool. So this puts kind of the boundaries for what is done in the next step. And to achieve this, one method is to further train the pre-trained models on so-called instruction data. And this step is called instruction tuning. And it basically works like this. You have the developers who define guidelines. And these guidelines could, for example, include that you always want the model to respond in a polite way, to talk in a friendly and approachable manner, and so on. And these guidelines I've taken, for example, from the Open Assistant guidelines, which is an open source project. And these guidelines are given to data workers. And these data workers are asked to write prompts. So, for example, a task description, and then also to write the answer, the desired answer to this question or a task. A second strategy that OpenAI has used, and that is the first line you see here with the red people. Maybe some of you are in there, because if you used the service before January last year or this year, OpenAI might have used your prompts and gave them to data workers who then wrote desired outcomes. So, and with these desired outcomes, we create so-called instruction data sets. So these are smaller data sets that include pairs of a task description and a desired outcome description. Another strategy that is closely related and often builds on this instruction tuning is called reinforcement learning with human feedback. And what happens here is that the developers prompt one or more models with tasks, and then they provide the data workers with different options of answers. This can be 2 answers, it can also be 4 or 5, and so on. The data workers are again provided with guidelines. In this case, from OpenAI, for example, that they had to rank the outcomes based on, are they helpful, are they truthful, and are they harmless? And talking to people here from the social sciences and humanities, you see all the red flags going on, because none of these terms is clearly defined. And it's very difficult often to find definitions of these terms that become so central in this adoption process. So with this data work put in by actual humans, we get human annotated or human labeled data sets. Data sets that contain, again, prompts and then rankings of desired outputs. And with this new data set, a so-called reward model is trained. And this model then in turn is used to evaluate future outcomes of the model. We don't need to go into detail here. The important thing to keep in mind is we have the developers providing guidelines, and we have the data workers who actually annotate and evaluate model outputs. Another way of adopting pre-trained models to specific domains or specific tasks is domain-specific fine-tuning. And this only means that we continue training a pre-trained language model on domain-specific data. And this is something that is particularly interesting, for example, for historians. If you know that the data or the sources that you're working with most likely are not included in the training data, but you have your own database with historical records, then you can continue training a pre-trained model on this data. Another example would be in medical healthcare, where, for example, patient journals are hopefully not part of the training data, but you want to apply the model in your healthcare domain, so you can continue training a model on this very specific genre. And you can also do this if you really want to make the model good in translation tasks, then you can continue training the model on specific translation data. Another method This is very basic and has been done for a long time in natural language processing, is working with classical rules and filters. And with that, I mean building systems that operate, if this happens, do that. So the way many of us maybe learned programming when we went to school, like really these if-then rules. And to do this, companies often use crowd workers, again, who are provided with large amounts of data, and then they are asked to annotate this data. And this is, you maybe heard about that, for example, OpenAI used crowd workers in Kenya who were exposed to immense amounts of very, very strong content. There is a podcast that I recommend to you from Karen Howe, who interviewed some of these workers and who described, for example, child abuse descriptions that these workers had to go through and annotate and give scores. How harmful is this? And this technology is used to build so-called toxicity filters or hate speech filters. And thanks to these kind of filters and the work of the people behind them, you can all use Twitter and Facebook today in a rather safe way without being exposed to those contents, because other people have done the filtering work for you. And this is one of the reasons why, for example, ChatGPT is considered quite safe today if you use it in English, because there are these heavy filter mechanisms. The last example, and this is something rather new, and I hope to see at least 10 dissertations on this topic, is something called constitutional AI, suggested by a company called Anthropic. And what they want to do is basically the same as reinforcement learning with the human feedback, but without the humans, because humans are quite expensive and it takes too much time. So they want to use the AI itself to evaluate model outputs. And they want to do so based on a set of principles. And this is where it gets really interesting. You can read their principles on the homepage. And they built a potpourri of a constitution containing, for example, principles based on the Universal Declaration of Human Rights. So, for example, they give the model the principle, always choose the response that most supports and encourages freedom, equality, and a sense of brotherhood. Or please choose the response that most discourages and opposes torture, slavery, cruelty, and inhumane or degrading treatment. They also include principles from Apple's terms of service, such as please choose the response that has the least objectionable, offensive, unlawful, deceptive, inaccurate, or harmful content. They include a sense of principles based, or that they called principles encouraging consideration of non-Western principles. And one principle here is, for example, choose the response that is least likely to be viewed as harmful or offensive to a non-Western audience. And then they have their own principles. For example, please choose the assistant response that is as harmless and ethical as possible. Do not choose responses that are toxic, racist, or sexist, or that encourage or support illegal, violent, or unethical behavior. Above all, the assistance response should be wise, peaceful, and ethical. So in this case, it's not a human that does the evaluation of an output, but the model is measured against these principles. And then in the next step, a reward model is trained and so on. So all these techniques, sometimes you only use one, sometimes you have a potpourri of many of them. You can also add other data sources and everything in this fine-tuning adoption phase. But what I really want to point out here is the decisions that are made in these steps. So it starts with the developers in the pre-training phase. Then you have the developers providing the guidelines for the data workers who do the annotation work in the adoption phase. And this really, I think, makes one more time very clear that what these models do is not magic. There are always human choices that determine what the models actually do and what they don't do. in next step, we come to the productification phase. And here we could focus on many different things, such as how is the user interface built, what kind of infrastructure is added, because, for example, you cannot, as a normal person like I am, I'm not able to use a pre-trained language model. I need an interface, and I need the infrastructure provided, for example, by a hardware provider. So in the step of the productification, we add these things and really build a product that can be easily used. And one part I want to emphasize here is the importance of the terms of service. And this is important. This is kind of a new skill that researchers have to develop now when using services like these, to understand what happens with the data that I use in these products. Because what these terms of service often do is that they more or less clearly define how the company behind the service may use your data. And very often it's the case that by the terms of service, you say that you have all the rights to your input data, so to the prompts that you provide. And in many contexts, this is very straightforward, and you can say, yes, of course, if I want the system to suggest an email to my sister and invite her to my birthday, I own the rights. But if I work, for example, with archival sources, the answer is maybe not as clear, because maybe the archive has copyrights, there are other copyright holders, or if my research is funded, maybe the research funder has rights on my data sources. So this is really important to keep in mind, because what you often do when using these services is you give the provider a right to use your input data, for example, for instruction tuning later and for optimizing the models. Terms of service also quite often include regulations of the type of data or the content that you may provide. And one example from Copy AI here is that you are not allowed to submit content through the interface that includes obscene, violent, vulgar, or offensive content, or content that promotes racism, sexism, discrimination, and so on. And why is this important? Well, I thought about it myself, and when I wanted to experiment with my own data sources, I was like, maybe I should not submit a copy of a court record describing, in this case, the stabbing of an enslaved woman, including the defense of the murderer, because this might be considered as promoting racism and violence. And I did not want to be cut out of the service. So I didn't even dare to try it out. But these are things that you, if you work with historical material, have to keep in mind, because we don't really know the principles of how these filters and rules have been built, and if they would flag this kind of historical context as well. As you see, let me see, just not I'm not missing here. Yes. Before I continue, if we take one step back again to the to this whole pipeline, these models are today often optimized for English language applications. So all this adoption phase, the fine-tuning, is done with English use cases in mind. And this is proving valuable if you use the models in English, because they are quite safe to use in English. But as soon as you switch languages, you run into issues that the models do not work as intended by the developers. Other issues are the terms of service, data privacy, and so on. And therefore, we think that it's very, very important that we in Europe build our own models and open models that are open for the public and researchers to be scrutinized, and so on. And therefore, we have, together with RISE and WASP, built the first generative language models for the Swedish and Nordic languages. And these models are called GPT-3. Just as a heads up, GPT-3 really is only one of these pre-trained models. It's not a product. We have not gone all the way through this optimization phase, because this is something that we want to leave to developers and researchers to do themselves, so that you can choose yourself what you want to use the model for, and based on that, further develop it. So this brings me to my next part, where I will provide you with some thoughts on the implications of generative AI for research in the arts and humanities. And one thing I'd like to point out is really that generative models can be used for more than just generating text. So they can really make some tasks such as summarization, classification, searching much more easier and more efficient. And depending on the different use cases that you find in your own field of expertise, all this will require that you have the knowledge about how the technology that you want to use, how this technology really works, and what the implications are for either your research, the results, but also for your research ethics and integrity. I also want to point out that generative AI really is only one little part of language technology, and it's quite hyped at the moment, but there are many other forms of language technology that for a long time have informed research in the arts and humanities, not least in Uppsala with projects such as the Gender and Work project, SWIGRAM, or the From Close to Distant Reading. And other actors in Sweden, such as the National Library, also develop language technology resources that can be used for very specific tasks and research questions in the arts and humanities and social sciences. Overall, when using these technologies as research tools, I would suggest always starting with the question of the problem. What is the problem I want to solve? And then always ask what model is the best to use or to solve this task with. Of course, there's a value in experimenting, because this is where you build knowledge, but it's always important to really ask, what is the actual problem I want to solve? And especially for example, PhD students, consider your time and the time it takes to get into a completely new technology and so on. So consider, what is the problem I want to solve? When you have decided that a generative language model might be a good solution, then I think the questions that, for example, historians ask when working with historical sources are exactly the same questions that we should ask here. How is the model built? This is equivalent to the question, why do I have this archival material in the first place? Who has collected it? Why does it exist? What has the model been optimized for? If it has been optimized to be safe, maybe it's not the best model to use if I want to look at court records from the 18th century dealing with slavery. Then, of course, the question about the terms of service. May I use my data in this service, or do I want to use my data? And then it's always about making considerations about the ethical implications, but I will skip this part because we might have some time in the panel later. If you want to find out these things, there are some things you can look for. Papers, research papers, usually most informative when coming from so-called open source initiatives or community efforts that develop these models. They usually document much more what they have done, how they have trained. You can always look for model cards, which are a standard tool now in the field to document how models have been optimized, how they have been trained. The data sheets, which is also a standardized form to document the kind of data that was used for training. And then, of course, the terms of service and privacy policies. And now I come to the last part, where I really want to encourage you to, well, of course, experiment and test these models, but also think about the role of your own competence for contributing to AI development more broadly, and how your competence and fields of expertise are needed in the wider societal debates about these new technologies. So Kate Crawford has written a really, really good book that I highly recommend, The Atlas of AI, where she problematizes the fact that, for example, justice is nothing that can be coded or computed. And that issues regarding justice or ethics or fairness always involve building an understanding for how AI systems interact with data, with workers, the environment, and the individuals whose lives are affected by the use of these systems. And I think this is really where the humanities and social sciences come in. If we think about AI development as a joint effort, where we need so many different perspectives who try to make sense of this elephant in the room together. Just as a thought experiment, as a historian, where do I see potential contributions? And these range from very concrete hands-on work to more societal engagement tasks. So, for example, I think that the questions that historians are trained to ask when it comes to, for example, source criticism, critically scrutinizing the power of the archives and so on, that these questions can inform the questions that, for example, data scientists and developers can ask. So, for example, the question, what sources do I have to answer my research question, can be translated to which data sets and data sources are available for the purpose of my model. And then so on, that you come into questions of the power of data. What are the silences in the archives, can be translated to who's not represented in my training data and why, and how can I mitigate this gap? Are there other archives or are there other data sources that I can use? Also very concrete documentation, where people in the humanities have very concrete tools for documenting large amounts of data or sources, as we call it. Something that has become more and more standard in the field of machine learning, the understanding that we need to document our data sets. And here I think not only historians, but researchers from the arts and humanities in general have a really good toolbox to ask the right questions needed to document data. Finally, and now we're getting more into the broader picture, I think the arts and humanities really must provide context and perspective to the ongoing debates. So, for example, sometimes you see claims such as this by the Galactica paper that this model has been trained on the corpus of humanities scientific knowledge. And I think many people in the humanities would immediately raise a hand here and say, oh, wait a minute, maybe not the whole of humanities knowledge and so on. Another example are the doomsday narratives that are circulating right now and that are really fueled by a few prominent figures. And here I think what people with a background in the arts and humanities can do is help the public disentangle differences between narratives and practical harms done by these systems. And also another field that I think where historians really can contribute is breaking out of these dichotomous ideas of this is either good or bad and so on, and contributing to a more nuanced debate where we focus on continuities. So not seeing AI as something completely new, but making visible the legacies, for example, from datafication, legacies in colonialism, surveillance, and so on. Because without knowing these things, it's really difficult to see these things continue in different forms in our future systems. So to wrap up, it's a joint effort, really, this AI development. And one very concrete way of how even you could tomorrow get involved in this in AI Sweden is that we have started a project called the Interdisciplinary Expert Pool for Natural Language Understanding. And this is a pilot project. It's really an experiment where we try to build a platform for knowledge exchange between the AI developers and subject matter experts. So people like you who really have a deep understanding of sources, data, and so on. We have started the project already in spring, but it's still possible to join. If you want, you find more information on the homepage. And I'm very happy that several people at Uppsala University from the humanities are already part of the project. And what is now happening in the project is we go now into the hands-on phase, where we, together with the members of this expert pool, for example, work on our own instruction data sets, so that the members of this expert pool provide input data for further developing models, as one example. So if you want about this project, you can read more on the homepage. And if you want to really know more, you can contact my colleague Danila, who is the project manager for that project. And with that, I stop.